Hello, my name is Carol Howell, and I'm Assistant Director for the Education Programs at UC Davis Center for Healthy Aging. It is my pleasure to introduce today's speaker, Dr. Bruce Reed. Dr. Reed is a professor of neurology at UC Davis. He received his training in neuropsychology at the State University of New York, at Stony Brook Duke University, and Braintree Hospital in Boston. He's devoted his career to understanding the effects of brain illness on mental function and behavior in older adults. His work has been supported by the National Institute on Aging for over 15 years, and he has published over 60 scientific articles. Dr. Reed is the Associate Clinical Director of the UC Davis Alzheimer's Disease Center. Welcome, Dr. Reed.
Thanks very much, Carol, and thanks for this invitation to talk about Alzheimer's disease, which is a topic that probably not many of us really like to think about, but is a topic that affects so many of our lives that it's important to know something about it. Alzheimer's disease affects 4 to 5 million Americans right now, and as we baby boomers get older to the age where Alzheimer's disease becomes common, it's really going to affect a lot of us. So I have organized this afternoon's talk around these questions. What is Alzheimer's disease? Will you get it? Can it be cured? Can it be prevented? And I'd also like to tell you a little bit about the research that we're doing here at UC Davis. But before I start on these questions, let me start with another question that I get a lot. It's one of the most common questions. What is the difference between dementia and Alzheimer's disease? And the difference is fairly simple. It's just this. Dementia is just a label for a set of symptoms. So if you come to me and say that your mother is having problems, and the problems are that she's having tremendous trouble remembering things, and she gets confused, and the confusion interferes with her ability to do everyday things. She's burning stuff on the stove, she's not getting dressed right, and so forth. I could say to you, well, it sounds to me like she has dementia. But what I've really just said is that she has memory and confusion that's bad enough to interfere with her day-to-day life. So I've just relabeled the symptoms that you told me about. Alzheimer's disease is an illness, a specific illness that causes those symptoms. So dementia is a label for the symptoms. Alzheimer's disease is a cause of the symptoms. And Alzheimer's disease is the most common cause of these symptoms. It explains probably 70 to 80% of these of the cases where there's these problems. And so it's a tremendously common disease. So let me tell you something about this illness. When talking about Alzheimer's disease, it makes sense to start with talking about Dr. Alois Alzheimer. Alzheimer was a German pathologist, psychiatrist, and a neurologist who worked around at the turn of the century. And he was really a scientific giant. In his time, he made a tremendous number of contributions to the study of dementia, which was the illness that he was really interested in. But to really appreciate what Alzheimer did, you have to understand how different the world was at that time. Of course, nobody knew that Alzheimer's disease existed because he hadn't discovered it yet. But in fact, Alzheimer's disease wasn't even that common then. And there were several reasons for this. One is that people didn't live very long. The average man, when Alzheimer lived, only survived to about age 45. And the average woman probably died a few years younger than that because of all the problems associated with childbirth. On top of that, we didn't have the medicines that we do now. So, for example, we had no way of treating high blood pressure. And as a consequence of that, strokes were more common than they are now. And there was no penicillin or any other antibiotics. And so syphilis, which can cause a dementia, in fact, was the most common cause of dementia in Alzheimer's time. And when Alzheimer started his work, he made real contributions. He published a number of important papers on syphilis and on vascular dementia. Vascular dementia is dementia due to strokes. But you can see when you read his papers that he felt like he was missing something and that he was seeing something else that was happening in the brain that was not explained by either of these two illnesses. And in 1906, Alzheimer gave a talk that presented the first case of Alzheimer's disease, and this is a case that he published in 1907. And when you look back, it's really kind of remarkable because in that paper, Alzheimer described all of the major features of Alzheimer's disease as we know it today, back in that first paper. So what he described was a patient who came in her late 40s, and she had suffered a course of progressive memory loss and confusion, began gradually and sort of slowly got worse, and it got quite bad. It got quite bad to the point that she couldn't function on a day-to-day basis. She didn't know the people familiar to her and so forth. He followed her for a number of years. When she died, he examined her brain very carefully using some new stains, some new methods that had been developed in Germany just a year or two before. And when he did that, he found the characteristic abnormalities that still define this disease today. So what you're looking at here is a slice of the brain under the microscope. These are not things that you can see with your eyes, but you can see them under the microscope. And there's two major abnormalities. These are not here in a normal brain. First is that there are amyloid plaques, sometimes called senile plaques, and you can see that up in this corner, sort of a large aggregation, a mass of these abnormal protein fragments. And the other are neurofibrillary tangles. And we'll talk more about these later, but these are just sort of tangled forms of a common protein that's no longer doing its function. Alzheimer saw these things. He knew that this was something new, and he believed that this was the cause of the disease of his patient's symptoms. And that is the way that Alzheimer's disease is still described today. Although we still don't understand perfectly, we understand a lot about them. And it's not so much that they're there that's the problem, but it's what they do to the brain, and they really do bad things. If you look at the brain in a person who's had Alzheimer's disease for a few years, what you see is that it's tremendously shrunken. And so there on the left, you see a brain that came from a patient who died with Alzheimer's disease, and on the other side is a brain that came from a person of a similar age without it. And you can see how much smaller that is. It's not uncommon for the brain to lose 1/3 of its weight over the course of Alzheimer's disease. And that's just an absolutely devastating loss, especially considering that not all parts of the brain are affected. And that's really the point of this slide, not that you have to know where everything happens in the brain, but the point is that different parts of our brain control different functions. Some control basic things like breathing and heart rate, some control movement and our ability to sense the world around us, and then there are areas that are really involved in our thinking, reasoning, and memory. And unfortunately, Alzheimer's disease specifically attacks those areas that control these sort of higher human functions of reasoning and memory. So, for example, this area here, these temporal lobe structures are very important to memory. These are the areas where the first symptoms of Alzheimer, or where those changes that I just showed you, the plaques and tangles, where they appear first in Alzheimer's disease. And that's where they cause their first damage. This is actually something that we can see to a degree using brain imaging techniques like MRI scans. Now, we're not actually seeing the plaques and tangles here, but what we are seeing is their effects. And what I want to show you here is that we can see this in a fairly specific way. So I want you to look right here, and what I'm showing you here is just sort of how we rotate the brain. So here you're looking at the side, front, back, spinal cord comes off here, and we've just artificially sliced it with our brain scanner, and now we turn it around, so you're looking sort of head on. and you're looking deep within the brain. And what we're interested in here are these structures, which are the hippocampus. The hippocampus is a structure that's critical for memory. It's critical for the formation of new memories and learning. And this is pretty much what you'd like it to look like in a normal older person. And basically you see that this light part, which is the tissue, pretty much fills up the space, and this dark part, which is normal, but it's just the spinal fluid that protects this, is there, but there's not a lot of it. When we look at this in a person with Alzheimer's disease, I think you can probably see, without even being familiar with these scans, how much less tissue there is here and how much more of this dark fluid there is. So this structure that's critical to memory has just been eaten away by this disease. And the worse the disease gets, the more atrophy we see, the more shrinkage we see. And so that late in the disease, it's quite bad, and you can sometimes it's hard to even see anything but the bare remnants of these structures that are critical for memory. As you'd expect, given that, memory loss is really the first and oftentimes the sort of dominant symptom of Alzheimer's disease. And when I say memory loss, I'm talking about a particular kind of memory loss. So I'm talking about the ability to learn and remember new things, not really facts out of a book, but I mean like what somebody has just told you, what you just did a few minutes ago, where you put something, what did you do yesterday. So the ongoing things of our lives, these all require memory. And it's that kind of memory, the memory for day-to-day current things, that is lost first in Alzheimer's disease. And sometimes families will be confused about this because they'll say, yes, but his memory's really pretty good because when we talk about high school, he can go back and he can name all his classmates and tell all these things out of the past and so forth. That is absolutely true early in Alzheimer's disease. The remote memories, the memories that were formed years ago when all this was there the way it ought to be and the brain was working the way it ought to be, those memories are still okay early in the disease. Eventually they are affected too. But again, it's the day-to-day, what we call recent memory, that's affected. And that, as I say, is the hallmark symptom of Alzheimer's disease. It's not the only symptom, though. And Alzheimer's disease really affects all of our thinking abilities. So I can show you some examples just to give you a sense of this. So for example, here are a couple of examples of copies of, over here, a clock and a house. And you see various kinds of mistakes there. Just, as I say, even now remember the person is looking at this while they're trying to do this. So you can see at a very basic level how much confusion there is. Or like this, when this is a situation where the person was asked to draw a clock, and you can see that in a lot of ways by this point, and this person was probably sort of moderately well along in the disease, even the basic concept of what a clock is beginning to go away. And this is something that you can see getting worse over time. These the drawings that I'm going to show you here are drawings of a clock. This is by the same man at 4 different times. These are about a year apart, and you can just sort of see how it starts off fairly good, but as time goes on, it's just more and more disorganized and spare, and it gives you kind of a feeling for what the progressive course of this illness is. And that, unfortunately, is one of the basic features of this disease, is that it is an illness that gets worse. It gets worse gradually. It's over a course of years, about 9 or 10 years on the average, although there's a lot of variability. It can run very fast, 2 or 3 years from beginning to end, can run as long as 20 years. But it is a slowly progressive loss of all of these abilities. I like to look at these pictures. not because they're pleasant to look at. They're really kind of sad, but they, I think, capture so much of the sort of progressive course of this illness. These are self-portraits that were painted by an American artist, William Untermolen, and one of the kinds of paintings he did were self-portraits. So these are of himself. In 1996, he was diagnosed with Alzheimer's disease, and he continued to paint self-portraits. And you can still see his talent, and you can also see what a devastating impact it has had. That is Alzheimer's disease in a nutshell. It is a progressive loss of abilities that profoundly interferes with a person's ability to care for themselves. Even early on, people have great difficulty doing the basic things of daily life. And in fact, I pretty much think that early Alzheimer's disease is incompatible with really living an independent life. People do stay, of course, in the community, but they need assistance and they need support to do so. And over a course of years, it progresses to the point that people cannot do the most basic things. That's a scary prospect. And when people think about this, one of the questions that comes to mind, of course, is, am I going to get it? What are my risks of getting Alzheimer's disease? And that's the way to think about it. What are the risks? What are the things that increase the risk of Alzheimer's disease? What are the things that reduce the risk of Alzheimer's disease? Now, I said that Alzheimer described every major feature of the illness that bears his name in that very first paper that he published. Wasn't quite right. He missed one feature of it, and the one feature was very important. He missed the fact that Alzheimer's disease is strongly linked to age. In other words, the older you get, the higher the risk is. Alzheimer actually thought that this was an illness that affected people in middle age. And he was so influential that literally for the next 60 years after Alzheimer published his paper, Alzheimer's disease was considered sort of a rare neurologic oddity that affected a very small number of middle-aged people. But some very influential work by some British neuropathologists in the 1960s showed that the changes in the brain in older people, who at that time were just called senile, were exactly the same as the changes, the plaques and the tangles that Alzheimer had described. And in fact, that there was no difference between these, and that with that realization, Alzheimer's disease changed from something that was thought to be sort of unimportant and obscure to something that was a tremendously big problem for society and for older adults. So, first question, if you ask me, will you get Alzheimer's disease? And I don't really mean this flippantly. The first, if you can tell me how long you'll live, I can tell you a great deal about what your odds of Alzheimer's disease are. Because the major risk factor for Alzheimer's disease is age. And also, as we'll talk about, family history. So as you can see, I hope with this curve, this just shows you how sharply the risk of Alzheimer's disease goes up with age. So if you look down here at around, under age 65, it's only about 1% of the population. But by the time you get up to, around 85, some estimates are as high as 50% of the population, but it's certainly in the 35 to 50% range. So for people in their 80s, this is a very common, very big problem. Interestingly enough, by the time you get to 90, your prospects probably improve as far as Alzheimer's disease go. Although it's not reflected in that curve, new evidence actually shows that the risks of getting Alzheimer's disease begin to go down after that point. But certainly up until then, age tells a lot of the story. Now, I said that family history makes a difference. Family history is really about genetics. And so to just just briefly review what we know about this. Genes clearly play a role in Alzheimer's disease. They probably explain a lot of the risk of Alzheimer's disease. A lot of that risk we don't understand. Here's what we understand at this point. There are 3 known genetic mutations that cause Alzheimer's disease. And I mean cause Alzheimer's in the strong sense of it, which is that if you inherit a single copy of this gene from one of your parents, and you live to the age of risk, which isn't that old in the case of these mutations, so 55 or age 60, there's basically a 100% chance that you get the disease. So in these cases, it is a genetic disease. And as I say there, all of these mutations are associated with very young onset Alzheimer's disease, sometimes beginning in the 40s, even the 30s. They all affect the production of amyloid, so that's those amyloid plaques that I was telling you about. But here's a very important thing to realize. All these mutations together only account for a small number of cases. It's probably under 5%. So the mutations can cause Alzheimer's disease. They do not cause most cases of Alzheimer's disease, but they have proven to be tremendously important discoveries because they tell us a lot about what goes wrong in the brain to cause Alzheimer's disease. So scientifically, they're very important, but they don't explain much. Most people who are in these families know it. I mean, if half of your family members are getting Alzheimer's disease by the time they're age 60, you know that. So most of these families know that they have a genetic mutation even before they see doctors like us. Now, in addition to these mutations that cause Alzheimer's disease, there's one major genetic risk factor that we know about at this point. So let me tell you just a bit about that. The major genetic risk factor that we know about at this point is Apolipoprotein E, which you'll sometimes hear this called ApoE. Apolipoprotein, as the name sounds, it is a protein. It's a normal protein. It's necessary for people to function normally. The protein itself is determined genetically. So there's basically a gene, and you have 2 copies of each gene. One comes from your father, one comes from your mother. And those 2 genes together determine this protein. Now, it turns out that just like eye color, which comes in different variations, there's variations of this protein. And these variations were just labeled E2, E3, and E4. So the number of genes that you have that code for this E4 version of the protein, so you can have 0, 1, or 2. The more you have, the higher your risk of Alzheimer's disease. And there have been a whole lot of studies that have shown very clearly that having 1 copy increases the risk, having 2 copies increases the risk quite a bit more. And people with the ApoE4 gene get Alzheimer's disease quite a bit younger than people who do not carry this gene. It's about a 10-year difference on average. So that's a big difference. Instead of an average onset in the 80s, it's an average onset in the early 70s. So this does have an impact on Alzheimer's disease. It is a risk factor, and I emphasize this because sometimes people ask, well, so why don't I just go out and get a test for this? Because you can. It's a genetic test. It can be done. There's a couple of reasons that we don't recommend it. First of all, as I say, it is a risk factor. So if you knew that you were carrying the E4 gene, you'd probably feel bad. And if you found out that you were not carrying it, you'd probably feel good. But you really shouldn't either way. And that is because there are certainly a lot of people who carry the E4 gene who never get Alzheimer's disease. And there's a lot of people, like 40% of the people who get Alzheimer's disease, who don't carry that gene. So it's a risk factor, and we can't translate that general risk into individual probabilities at this point. But again, this is something that has helped us understand a lot about what goes wrong in the brain with Alzheimer's disease. So, age tells a lot of the story. The genes tell part of the story, and as I think as we go on in the next 5-10 years, maybe even less, we're going to learn a lot more about the genetics of Alzheimer's disease. But I don't think it's going to be the sort of thing that just single genes cause the illness in the strong sense of the word. A lot of risk factors, I think, is what we're going to learn about in the next few years. Now, Alzheimer's disease turns out to be complicated, and there are other risk factors as well. And you can't do much about your age, and you can't do anything about your genes. There are things you can do things about. Let's talk about these. I call these secondary risk factors because they're not as strong as the first couple I talked about, but these do matter. So, head injury, low education, mental inactivity, a sedentary and a non-active lifestyle, and cerebrovascular disease or strokes. So let me talk about these a little bit because all of these raise the risk of Alzheimer's disease. I use this picture partly because I like the picture, but this was the picture that the New York Times ran that accompanied the obituary for this man right here, who was Jerry Quarry. Jerry Quarry was a pro boxer who died in his early 50s after several years of a dementing illness. And most of you will know that Muhammad Ali also has a brain illness at this point. It's not Alzheimer's disease, but it has affected him greatly physically and mentally as well. And I'm baffled sometimes if people think that this is not bad for your brain. Don't do this. Don't get a head injury. It raises your risk of Alzheimer's disease. I think that's pretty self-evident. What about some of these other risk factors? Education. Education is really an interesting thing. First, let me explain what you're looking at here on the graph. As it says, the risk of Alzheimer's disease goes down as your level of education goes up. In this study, what we're doing is just looking at the risk of Alzheimer's disease in relation to schooling. So over here, you have people who finished only grade school. And you can see that compared to people who have a college education, these people have 4 times the risk of Alzheimer's disease. And this kind of finding this is very reliable. This has been found in a lot of studies. And it's really intriguing. A number of questions come up about this. And without going through this whole story, there's a couple of possibilities that people think about as to why this is so. Perhaps the most interesting is that education, even during your childhood years, may do something good for your brain that protects you in later years. And this isn't quite as odd, maybe, as it sounds. When you do things, when you learn things, when you experience things in the world, there are changes in your brain that reflect those experiences. Your brain, in other words, your brain changes as a result of the experiences that you have. And this is it's kind of a key capacity of the brain, and it's well known. So one of the ideas is that when people go to school and spend all the time studying, using their brain, that actually builds up connections between the different cells in the brain, builds up systems in the brain that then later, when the brain comes under attack from something like Alzheimer's disease, actually protect the brain from feeling the effects of that illness. So that's a very interesting idea because although by the time you're my age, you're not going to go back to school, it does raise the question, well, what about after you get out of school? Are there things that you can do are there things that you can do at that point that still make a difference? And the answer to that seems to be that yes, there are. So, for example, there's different ways to look at this. This is a study where basically the researchers asked people, what do you do with your leisure time? And so, of course, some people kind of sit and watch TV all the time. Some people do things like read books and do crossword puzzles and Sudoku puzzles and whatever. And so they just looked at sort of what people do, how much thinking it demanded, and then looked at what the risk of Alzheimer's disease was. And what you see here, this looks an awful lot like the chart I showed you about education. So the people who had the lowest level of sort of leisure thinking activities had the highest risk of Alzheimer's disease. The people who did the most stuff that really demanded that you think had the lowest risk of Alzheimer's disease. And again, it's quite a bit of difference. These people have only about 30% of the risk of these people. So that's a big difference. And so this, again, is something very interesting because these are things that we can do something about. Now, I have to say that this is not proven. This is really an area of intense interest, but it's not proven. And there is another idea, which is that it turns out that education is good for your health in almost every way that you can imagine. With a few exceptions, you name the disease, more educated people get it less. And when you see that kind of pattern, you think, well, maybe this has something to do with something, not just the brain, but with much broader factors. And so it may have to do with things like very broad lifestyle things. It may have to do with access to health care. Maybe people who are better educated make more money. We know that. They live in better neighborhoods. They have health insurance. They go to doctors. They're more likely to do all the things that keep you healthy in general. So it's possible that education does not actually directly affect the brain, but it affects your health in general, and that it protects you against a whole lot of things, and that Alzheimer's disease is one of those things. I personally don't think that's the whole story. I think that education and mentally stimulating activities probably do something good for your brain. But as I say, that's not totally shown at this point. What about some other things? What about not just mental activity, but physical activity? Well, again, the same sort of thing. And without going through all of this, if you just sort of focus on the dementia group here, again, the people who were inactive had the highest risk of Alzheimer's disease. And then it's kind of, if you got off the couch at all, your risk went down quite a bit, and didn't make a whole lot of difference whether you walked a little or ran a lot. Your risk was lower. But that's also encouraging, because that's another thing that we can do something about. When we see this is sort of a sample of a very interesting story that's begun to emerge over the last decade, which is that there are a lot of things that we know that people can do to keep their hearts healthy and to reduce their risk of stroke. And very interestingly, it turns out that a lot of those also protect people against Alzheimer's disease. So this is one example. Exercise is good for your heart. It reduces your risk of stroke, also reduces the risk of Alzheimer's disease. Or here's another example. Fat intake. You hear all the time that you shouldn't eat too much fat. Well, this is another reason you shouldn't eat too much fat. Again, the people who ate the most, these groups over here, had the highest risk of Alzheimer's disease. Those who ate the least had the lowest rates of Alzheimer's disease. Once again, the same story you're seeing in all of these graphs. And so it turns out that when you line up the risks for stroke with what we found out about the risk of Alzheimer's disease in the last decade, they really line up very, very nicely. And this has really sort of opened up a new area of investigation, and it's one that we've been very interested in at Davis, is what is the connection between stroke, the risk factors for stroke, and Alzheimer's disease. And there really does seem to be an effect. So this is just showing you some results of study that we did in the Sacramento area. This was looking at Hispanic elders. And the basic point of this is that, okay, these are different age groups here, and this is what we've got here is the risk of the number of people who had Alzheimer's disease. And we've put different lines on here to show how much risk they had of stroke. So if they had a history of stroke, that's these people. If they had diabetes, that's these people. The people who had both is this group. And you could see this group has a tremendously higher risk of Alzheimer's disease. So again, just more evidence of the same story. So this, when you go back to those slides that I showed you initially, you can deceive yourself and think that Alzheimer's disease is kind of a simple disease. The plaques and tangles accumulate in the brain. Those harm the brain. They kill the nerve cells. The brain shrinks. You can't think. That's what goes wrong. But it's really a much more complicated story than that. And what I'd like to do now is show you a series of slides that really emphasize just how complicated this is. So what we have here, okay, let me first explain the background here. These results come from a study that was done in the Chicago area. And what the researchers did is they went out into the community and they found people who were mentally healthy, these older adults who were mentally healthy. They followed them for many years, testing their memory and mental abilities very carefully. They followed them, and they're still following them to the time they died. This report came out on the first roughly 140, 150 people who had died. And what they did then was look at the brains of these people who had died, and they compared what they found in the brain of normal people, and those are the people here in this sort of brown-orange, with the people who had dementia. And they looked at different kinds of changes. They looked at Alzheimer's changes, the plaques and tangles, and they looked at some other things that can go wrong in the brain. So let's just walk through this. So when you look and you compare whether there were changes of Alzheimer's disease in the brain, start here. These are people who are demented. And you see that 85% of them had changes of Alzheimer's disease. Okay, that makes sense. We expect that. But here, these people, remember, these are people who'd been tested by psychologists very carefully with memory tests and so forth. They were normal. Over 40% of these people also had changes of Alzheimer's disease in their brain. And this, incidentally, is not the only study to show this. Every community study that's looked at large numbers of older people finds maybe not this many, but probably 20% at least of people who function normally and have a lot of what we call the pathologic changes of Alzheimer's disease in their brain. Now, they went through and they broke this down a little bit further. So let's just go through this. If you looked at people you looked at the cases that only had the changes of Alzheimer's disease in their brain, no other change, just Alzheimer's disease, and you compared the demented and the non-demented, very little difference. If you looked at the cases who had Alzheimer's disease plus something else, and the something else might be like Parkinson's disease or it might be a stroke, now you're seeing a pretty big difference. And when you really focused on stroke, so Alzheimer's disease plus stroke, you see a huge difference. So it was pretty unlikely that a person who was normal would have both of those changes. And on the other hand, if you had both of those changes, you can see how likely it was you had dementia. So the story in Alzheimer's disease is not so simple. These results and results like this have shown us, first, that it's very possible for people to get the changes of Alzheimer's disease in their brains, but not lose their memory and other mental functions. And also that the combination of Alzheimer's disease plus something else really seems to be especially bad for the brain. And it's really trying to take a look at these kind of effects that is what UC Davis is very interested in. So let me just say a bit, just briefly, about the research that we're doing at some of the research that we're doing at our center. The basic point here is that there is a lot of variability in how people, when I say cognitive aging, I mean, how does your memory go as you get older? Does it stay normal? Does it fall off a little bit? Does it fall off a lot? Well, as I say, there's a lot of variability. Some people stay almost the same. Some people change a little, and then there's the people with Alzheimer's disease who change a lot. Why? It has to do with a lot of the reasons I've just been talking to you about. But we can line up a lot of potential differences. Differences in genetics, of course, exposures, experiences, the things that people do throughout their lives and encounter through their lives. Other illnesses that they have, and then, of course, the illnesses that actually directly affect the brain. And one of the challenges is to understand how important these different things are, how they add up to actually cause the different symptoms. Now, just a basic thing when you're trying to understand this kind of problem is that you need to study people who have got a range of different experiences in this area. In other words, if you study people who have had all the same level of education, who have all the same level of healthcare access, who live in the same environments, you can't see how these things affect people. So what's a way to get variability in that? Well, one way is to study an ethnically diverse group of people, because unfortunately it's a reality in this country that ethnicity and minority status goes along with a lot of other things, like lower education, like less access to health care, exposure to worse kinds of environments. African Americans have much greater rates of hypertension than do whites. Hispanics have much higher rates of diabetes than do whites. So we have really made a point of going out and trying to get very diverse groups of people. We've reached out to the community to try to get people from minority communities who will join our research so that we can try to understand these factors. And when you look at all the things that I was just telling you about that seem to raise your risk of Alzheimer's disease, you might ask, well, are minorities more likely to get demented or more likely to get Alzheimer's disease than Caucasians? And unfortunately, there is evidence that that is the case. And so this is just one of these studies. And again, what I've got here is the risk or the percentage of people with dementia in this large study that was done in Manhattan. And you can just see across all these different age groups, these people here, these are whites, these are Latinos, and these are African Americans. And you can see the rates are quite a bit higher, which in itself is another reason to try to enroll minority participants in research, because you ought to be studying the people who are affected by an illness. So trying to use ethnicity in a way to get a diverse sample that helps us understand really what the different kinds of life experiences are that affect that may increase your risk of Alzheimer's disease, but also may protect you against Alzheimer's disease, is a real focus of our research. And we do this in various ways. We use a lot of brain imaging. So these are pictures of MRI. MRI is very good at showing the shrinkage of the brain that I showed you initially. It's also very good at showing strokes. It helps us measure the health of the brain in many ways. Now, I do want to emphasize that in these standard sort of MRI scans, we can't see the changes of Alzheimer's disease. We can see the effects of Alzheimer's disease, but we can't see those plaques and tangles. But there is some very exciting research that we're also involved in at this point, where there have been new methods developed literally in the last 4 years that for the first time let us detect these things in living people. And this is showing examples. These brain images came from our collaborator, Dr. Jagist at Lawrence Berkeley Lab. And these are PET scans, and I'm not going to go through the whole explanation of how this works, but basically what this does is create a map of where those amyloid plaques are in the brain. And red means that this is a high level, and blue means that there's a very low level. And so you can see this person over here has a lot of amyloid plaques in their brain. And this, in fact, is a person with Alzheimer's disease. This was a similarly aged person, and these levels are actually very low and normal. This is nothing significant. Now, this person's very interesting because these levels are getting to be high. This is actually an elderly gentleman who seems to be functioning just fine at this point. And we have no idea whether he's really developing Alzheimer's disease or whether there's something about him that's going to protect him for many years against the effects of these changes beginning in his brain. But using these kind of brain scans, we can begin to understand these things for the first time. So that's one of the interesting things that's on the horizon. Let me turn to the last two questions that I proposed at the beginning, which are, can Alzheimer's disease be cured and can it be prevented? Well, right now the answer is no. Right now there's no cure. Can it be prevented? Not completely. It may be that a combination of these things we've been talking about, mentally stimulating activities, physical activity, these kinds of things can make a difference. But it cannot be prevented completely at this point. But there is a lot of very interesting work on the horizon, and I just want to talk about that for a few minutes. Let me just remind you again of the two basic things that the basic abnormalities that Alzheimer saw in the brain. He saw these amyloid plaques, and he saw these tangles, and these tangles involve an abnormal form of a common protein called tau. Alzheimer knew nothing about how these things appeared in the brain. One of the things that has happened over the last 20 years is that we have learned a tremendous amount about how these things begin to appear in the brain. This is just sort of a cartoon, an artist's representation of what goes wrong. This is a nerve cell in the brain, a neuron, and this is a protein called APP. It just stands for amyloid precursor protein. So it's a protein that amyloid comes from. Again, this is a normal protein. It attaches itself to the outer wall of the cell, and it just sits there like this. Now, what goes wrong in Alzheimer's disease is that enzymes come along and they cut this protein at two places, one out here and one actually in the cell wall, into very short fragments. And it turns out that these fragments, these little pieces of this protein, seem to be quite toxic to neurons. And even in this form, when it's very hard to detect them, they're very poisonous to nerve cells. They accumulate in large numbers. They begin to sort of glom together, and they eventually form plaques. Once the plaques are formed, for reasons that we don't entirely understand at this point, they begin to affect the tau protein in a way that makes it break down. So what's the function of tau? As many of you know, neurons, which are the sort of thinking cells of the brain. They do the brain's thinking work. Neurons have a body, and then they send out long arms that they send signals through, and they communicate with other cells. So these long arms of different neurons reach out, and they connect to each other, and it's that allows the neurons to communicate with each other and the brain to work. Now, if a cell has a long arm like this, you have to have something to keep that arm healthy. It needs to get nutrients and so forth. And actually, the cell forms little tiny tubes along these long arms that carry the nutrients and so forth that the cell needs. And tau is sort of the building block of these tubes. So it lets these tubes form correctly and stay in place. Once these tangles, once these plaques get started in the brain, something goes wrong and the tau doesn't work anymore. And instead of getting these nice, stable tubes, it all collapses into just a tangled mess. The tubes don't work anymore. It's very bad for the neuron, and the neurons die. So, as I say, we've learned a lot about these processes. And the more we know about these processes, the more clues we have as to ways that we might intervene. So, let me just show you one that's been very exciting. When you think about how could you interrupt this whole cycle? Well, I've talked a lot about amyloid and what the bad things it does for the brain. If you could do something to take away those little pieces of the amyloid when they're toxic, if you could get that out of the brain, could you stop Alzheimer's disease from developing? Well, there have been a number of scientists who have been working in this area, and these were some of the preliminary results that came out a few years ago. They were very exciting. What they did was a very clever approach. They had the idea, maybe you could immunize a person against this amyloid, because maybe you could trigger an immune response so that the body would recognize this as a bad thing, and the body's natural processes would clear this out. They first tested this in mice, and so one of our scientific advances of the last 10, 15 years is that we've learned how to give mice Alzheimer's disease. This, one of the challenges in studying Alzheimer's disease has been that it was only a human disease, but with some of the magic of genetic engineering, we can now put the mutations that cause Alzheimer's disease into mice and give mice Alzheimer's disease, which is bad for mice, but it's very good for us because we can now do things that we could never do with people, and it's advanced the science tremendously. So this shows you an example of this. These are slides taken from mouse brains. Mice get old in a hurry, so these are probably like 16 weeks old or something. And what you see in these dark areas, this is the amyloid. This is essentially like the human amyloid that's accumulating in the brains of these old mice. Now, these are pictures of brain tissue taken from mice that had been immunized against the amyloid. And you could see they're clean. The amyloid is gone. Now, so this was, as I say, this was tremendously exciting. And researchers pressed ahead to apply this to people. And this shows you slices from a human brain that show essentially the same thing. Up here in this dark area, you see a lot of amyloid. Here, in a person who had been immunized, you see it's almost clear. Now, unfortunately, this clinical trial was stopped. It was stopped because a significant percentage of the people got sick, I mean seriously sick. A number of them died. It turned out, this was a great disappointment, there was, for reasons that are not totally understood, but seem to have to do with the way the immunization was done. People don't tolerate it very well. But as an idea, it's tremendously exciting. And it's one of the things, along with several others, that scientists are pursuing really vigorously right now. So if we look ahead to what's on the horizon, there really is hope for the future. So there's a lot of research going into all of these approaches. So for example, anti-amyloid drugs. If you could do something that would block the formation of the amyloid or get rid of the amyloid after it's formed, you could stop these plaques from developing in the brain. And maybe if you could do that, you could stop the whole chain of events that goes wrong in Alzheimer's disease. So there's a lot being done here. The immunization approach is still being used. There are new approaches that seem to be much safer that are being experimented with now. We just completed one of these trials in cooperation with industry at UC Davis. There's others that are going to be coming up that we will be involved in. This is a very exciting area of potential benefit. What about tau? We just talked about what goes wrong with tau. Well, maybe you could come up with a way to stabilize tau, protect it, so say the amyloid begins to form. If you could protect the tau from it, you could prevent the tangles from forming. The neurons would still work well. Maybe you could save things at that point. Or we understand a lot about why cells die and why they die in the sense of no matter what affects them, there are certain common things that go wrong when a nerve cell begins to die. So this gives us clues as to what we could do to protect cells against dying. So you could say, even if some of the amyloid forms, even if tau and the tangles form, maybe there are things we could do to protect the cells against that, maintain the cells, so you could protect against cell death. That's another approach. Or, as sort of the last hope, say things have gone wrong, cells have died, is there any way that we could repair it? Well, this is the great hope of stem cells, and this is why so many advocates for Alzheimer's research are very passionate about stem cells, because this is potentially, and I think many, many years off, but potentially a way that scientists could come up with ways of restoring the brain after it's been damaged. So none of these things are about to appear now, this year. There are a lot of them on the horizon, and I think they offer tremendous hope as we go forward over the next 5 or 10 years. So with that, I just want to say that research on Alzheimer's disease can't progress without public support, and public support really translates into money, but also the dedication of people out in the community who volunteer to take part in studies or who have their loved ones who are affected by Alzheimer's disease take part in studies. All the research depends on people like that who give time and effort to support studies. And we've had a lot of support from this community. We thank the community for that support.